हेलो एवरीवन एंड वेलकम टू दिस चैनल। तो आज हम लोग करने वाले हैं एनालॉग इलेक्ट्रॉनिक्स 1 में हमारा अगला टॉपिक दैट इज इनपुट एंड आउटपुट कैरेक्टरिस्टिक्स ऑफ अ कॉमन एमिटर ट्रांजिस्टर। सो वी आर गोइंग टू यूज द सेम डायग्राम जो कि हमने प्रीवियस वीडियो में यूज किया था। एंड हियर VBB एंड VCC आर द बायसिंग पोटेंशियल्स एंड VB इज द इनपुट वोल्टेज whereas VC is the output voltage. Now to get the input characteristics हमें ग्राफ बनाना होगा between IB and VB for different values of VCE. And in case of input characteristics हमारा ग्राफ similar रहता है by a forward bias diode. तो यहाँ पे हमने हमारे IB और VB axis मार्क कर दिए हैं and initially हमारा जो voltage होता है that is 0, but after some time when VB is much greater than VB there is an exponential rise. Now we have to see that जब हम VC की values को deflect करते हैं how does the graph changes. So उसके लिए we will have to take a look at the early effect. So first of all we know that VCE is equal to VCB plus VBE. Now we have taken this NPN transistor diagram. हमने जहाँ पे हमारे immobile ions हैं हम उस width को W मान रहे हैं, जहाँ पे हमारा recombination of electrons and holes take place करेगा उस width को हम लोग W effective मान रहे हैं and the width of base is considered as WB. तो इस पर्टिकुलर इक्वेशन को हम लोग लिख सकते हैं दैट इज W effective is equal to WB minus W. So if we increase the VC, we can see that VCB will also increase and since the VCB is increasing, हमारा WB increase करेगा. Now from this particular relation we can say that जब हमारा W बढ़ रहा है, our W effective is going to decrease and since our W effective is decreasing, तो जो हमारे पास space होगा for the recombination of holes and electrons वो decrease होगा, जिसकी वजह से हमारा IB which is the input current will also decrease. So now if we have to see this graphically, so here we can see that the red plot is for VC equals to 20 volt and as we decrease the value of VC हमारा graph left side की तरफ shift करता रहता है. Now let us talk about the output characteristics. So for the output characteristics we have to draw the graph between IC versus VC for different levels of IB. Now we know this expression that is IC is equal to beta times IB plus beta plus 1 times ICBU. अगर हम लोग IB को 0 assume कर लें, so we will have our collector current is equal to beta plus 1 times ICBU, where ICBU is the reverse saturation current. तो हमने initially वही plot किया that when our IB is equal to 0 milliamperes, then our voltage is equal to beta plus 1 times ICBU and we can just call this as whole term as ICEU. That is the reverse saturation current in case of common emitter. And as we increase our values, we can see that IB is equal to 0.1, we get our IC as 5 milliamperes and IB is equal to 0.2 milliamperes, we get the value of IC as 10 milliamperes. अब यहाँ से हम लोग बीटा की वैल्यू भी कैलकुलेट कर सकते हैं. So for that we have the formula that is beta is equal to delta times IC by delta times IB. So we have the values as 10 and 5. So 10 minus 5 divided by 0.2 minus 0.1. So from here we will have the value of beta as 50. अगर हम बात करें हमारे regions of operation की, so this particular region is known as the active region because यहाँ पे हमारा amplification take place करता है. This particular region is known as the saturation region and this particular region is known as the cutoff region. So that was all for this video and I will see you in the next one.